cursor down here. Okay, so we're ready to start problem number 14. This is on gender selection. And it says the Genetics and IVF Institute conducted a clinical trial of the Y-sort method designed to increase the probability of conceiving a boy. As of this writing, 291 boys or babies were born using this method. And 239 of them were boys. That's what they were looking for. Use an alpha equal 0.01 significance level to test the claim that the Y-sort method is effective in increasing the likelihood that a baby will be a boy. So in our null hypothesis, the proportion of boys is typically 0.5. So our alternative is we believe that by this method it will be greater than 0.5, the population proportion. Okay, so we're going to have the same critical Z that we had in the last problem, because we have 0.01 here, and so our area is 0.99 00, which is closest to the 2.33 that we got the last time. Okay, so our test statistic, and here's our critical region. Our test statistic, Z, will be the 239 over 291 minus the 0.5 times the square root of 291 all over the square root of 0.5 times 0.5 is going to be 0.25. Okay, so 239 minus clear. Let me start over. 239 divided by 291 minus 0.5 equals times square root of 291, close that off, equals divided by, that's going to be a 0.5. So I'm getting 10.96. So that's way out here, definitely in the critical region, so we're going to reject the null hypothesis. Okay, and if we look back at our table on 391, we have the claim does not include equality and will reject. There is sufficient evidence to support the claim that there is sufficient evidence to support the claim that the Y-sort method is effective in increasing, and I'm taking this straight from the problem, the likelihood that a baby, whoops, I'm writing uphill, baby will be a boy. Okay, let's do that one on the calculator. I think a lot of what we already have in there will work. So again, we're going over to tests. We want the one proportion test, so that's number 5. P sub 0 has 0.5 again. We just need to change our numbers here. Okay, X is 239. N is 291. Our alternative is greater than, so we just want to come down and calculate. Okay, again, let's compare this to what we have in our notes that we just did. All right, so here's our alternative hypothesis. 10.96 is our statistic. We can see that's there. Our p-value is extremely small. Look at that. It's 27 zeros and then 2. I mean, you might as well say that's pretty close to 0. So certainly that is less than alpha. So the p-value method would also give us reject the null hypothesis, which would lead us to the conclusion there's sufficient evidence to support the claim that the Y-sort method is effective in increasing the likelihood that the baby will be a boy. All right, let's do the next one just using calculator, and I'm just going to jot down some of the numbers. We'll do number 18. In a presidential election, 308 out of 611 voter surveys said they voted for the candidate who won. So X is 308 and N is 611. We want alpha to be 0.10. So to test the claim that among all the percentage you believe they voted for the winning is equal to 43%. So H sub 0 is our claim. P equals 43%. Okay, so when that's our claim, then we have not equal to for the other one. All right, and then the percentage who believe they voted is equal to, which is the actual percentage of votes for the winning candidate. What does the result suggest about voter perception? Okay, so let's see. Let's try this one just with the calculator. So I'm going to reduce this down so we can see it in the calculator window, and I'm going to clear this out. Whoops. Okay, I may have to come back to this later because it's going to disappear every time I click on something on the calculator. Let's see if I can type. Okay, I'll just refer to number 18 to get my numbers. Okay, so we want to go to Stat, over to Tests. We want number 5. All right, our proportion has changed. This time it was equal to 43%. All right, and we had 308. Thought they had voted for the winning candidate. All right, and out of 611. And our alternative this time, we want to press enter to choose that and calculate. All right, now I can pull my notes up here. Okay, so when we look at this, we see what the test statistic is. The only thing is at this point I did not look up the critical values for 0.10. So P though is 2.16 times 10 to the negative 4. So that's going to be 0.000216 is our p-value. So that's very small. Certainly it's less than this. So if P is low, the null must go. So we're going to reject the null hypothesis. So basically when you're using the calculator alone, you're just looking at this. Now the problem is on the exam I am going to ask you to do it with the critical value method, but certainly you could use the calculator to check your work. Okay, so let's think about our conclusion, how we want to word that. Okay, so the claim is the null hypothesis. We're rejecting it. So that means there is sufficient evidence to warrant rejection of the claim. And then I get that from the table on page 391. Then I go back to the problem. And claim that 43% of all voters believe they voted for the winning candidate. Okay, write it so we can read it. So there appears to be this was the actual number, and there seems to be a big discrepancy from what the people said and what actually happened. So I would say that maybe they lied or they forgot or something, that there is a big difference between how they said they voted and how they actually did vote. So that's what's going on in this problem.